isn't you require to prove it as theorem. It is actually a theorem. नहीं NCERT बुक को छोड़ दीजिए. मैं ये कह रहा हूँ कि this is actually not a theorem. This is not actually not an axiom. That is what I trying to show in this lesson. What were the initial axioms? Initial axioms are nothing but the 5 postulates. Everything else is proved in the book. And that is what the wonder is. मैं तो इक्लिप्स के बारे में उसके बारे में सोचता हूँ तो मेरे रोंगटे खड़े हो जाते हैं. 13 books, all the maths known at that time, and not one thing out of place. From top to bottom, nowhere does he use a result which is proved later. Everything is in a sequence. Okay, so this is the problem that I have. You see, at school level, I did a construction which proved that every triangle is isosceles. I couldn't find a fault. I know it is wrong. Couldn't find a fault. I wrote to every author that whose book I was looking at. Nobody replied. I hope they got the letter, but I think they didn't know what was wrong with the proof. But that is exactly what we are worried about. I mean, which theorems are true, which theorems are false. What can I assume? When I want to prove congruences, should I assume this, or should I assume this, or should I assume this? Which one should I assume, and why should I assume this? Yes, so सास यहाँ पे बहुविध है तो क्या करते हैं? ठीक है? So what should I assume? What should I not assume? So this is the type of thing that I am saying. What assumptions can I make? What assumptions can I not make? This is the thing that you have to teach. If you want your students to go out and use maths, whatever career they choose, then this is the lessons that they have to learn. When you see a practical problem, what can I assume into this problem? Can I assume that my management is going to be honest? When I am working, can I assume that my constructor for the bridge will provide me the right quality of cement? Can I not assume it? Can I have to work for it? This is what a mathematician does. He looks at a real life problem and tries to make out what are the assumptions I can make, what are the things that I can use, what are the things I need to prove. So what I am saying is that we are not trying to train people to do mathematics. Some of them will do math. I don't want 1 million mathematicians popping up. Like I don't want 1 million MBAs or 1 million engineers. But mathematical thinking is a way which helps in real life problem solving. In fact, one of the reserves in South Africa was having a massive problem with the local population and preservation of the wildlife. Ultimately, a solution was provided by a mathematician who came down, wrote down all these things, worked out a scenario, worked out an axiomatic system, and then stated that as a theorem, you have to do this and you have to do this, you have to do this, and everybody believed him ultimately because it is a theorem of mathematics. And it works. That place is doing better now. So, mathematician's job, our job is to train people in mathematics and not just to make them good at calculus. What is the point of irrational numbers? 99.99999% of the time, he will never use pi in his life. बाजार में जाएगा वो कभी भी उससे ये नहीं कहेगा कि पाई आलू दे दो. Rational numbers के अलावा he will not use any irrational number. Why do you want to teach? He never use compound ratios. Never in his life. So why do you want to teach? Even as a mathematician, he is not going to use compound ratios very well. If he needs to, at the level he is, reading it once, he will understand what compound ratio is. There is no point teaching. So, at school level, when we are teaching a subject, we are not teaching the subject to make them professionals in that subject. We are teaching them the subject so that if they want to become a professional, that's also okay. But if they want to use it, see what is the benefit of doing. What is the benefit of doing physics? What is the benefit of doing chemistry? What is the benefit of doing English, or French, or history, geography? If you don't understand the history or the sociology of, you will never be able to handle the country's problem. You don't understand even the history of the country, what is sociology. Not training them as sociologists. Even as an economist, if I want to go and solve the economics problem in the country, I need to know the sociological structure. I need to know maths. How do I prepare budget? How do I do without doing some probability analysis? What is the probability that so much of demand will be there for this? So everybody needs all sorts of things. So our job is to try and tell them that you have to start thinking. These are the tools that we are giving. Calculus is just a tool. Geometry is just a tool. I can teach you how to use a spanner. I can teach you how to, but where to use the spanner? वो उसको बिजली का काम है जो spanner लाके उसको मारा, हथौड़ा मारा, क्या करेगा? तेरे को झटका ही लगेगा, मरे जाएगा अपने स्टूडेंट क्यों मार देता? नहीं चल. Our object is to try and tell them what the way we think. So, okay, so Euclid, by the way, at that time, just because they are called Euclid's elements or Pythagoras theorem doesn't mean that Euclid wrote all the 13 books or Pythagoras wrote it. There were schools at this time, schools being collection of faculty and students, and there used to be a leader and the school was known by the name of the leader. Anything that came out of the school was attributed to the leader. So Pythagoras theorem came out of the Pythagorean school. Euclid's elements came out of the Euclidean school. Okay, so it's not that he wrote down everything, but it did collect all the works, and these are the 13 books. The first 4 and the 6th one talk about plane geometry, that means geometry in a plane or 2D geometry. 5th talks about ratio and proportion. 7 to 9 talks about theory of natural numbers. There he talks about prime numbers, Euclid's division lemma, and all those things. 10 talks about irrational numbers, because without irrational numbers you cannot do solid geometry also properly, because you want to talk about A cubes, volumes and things like that. Solid geometry or 3D. Okay? Now, can you guess why there is a break in plane geometry? After doing 4 chapters of 2D geometry, why all of a sudden he wants to do ratio and proportion and then come back to
now there is a break
Why do you think this happened? Because he wanted to talk about similarity. When are two triangles similar? With the ratios of the corresponding. So he couldn't do it without really putting ratio on a firm foundation. So till 4th geometry he is only talking about congruences and things like that. No similarity is discussed. It's only in chapter 6 that he talks about similar triangles. He defines similar triangles and then he proves the various conditions. All the various conditions of congruences are proved in chapter 1. Okay, so I probably have run out of time, have I? Okay, so I've run out of time, so we have run out of time. Thank you. I haven't really told you what the axioms and what the postulates are. This is what I wanted to do in this. But maybe I can send a PDF file of what are the various objects here. But in the book 1, he gives 23 definitions which define all the basic objects like point, line, angle, right angle, obtuse angle, circle, arc, radius, diameter, all those things. Common notions are basically the rules of the game that you can use things like if A is equal to B and B is or C is also equal to B, then A is equal to C and things like that. Okay? These are the things that I would like students to understand. Propositions are the theorems that he proves, where he proves all the SAS, SSS and everything. Also the 47th theorem is the Pythagoras theorem and 48th is the convex. So let me just give you a site of a university called St. Andrews. This is of Scotland. इनकी वेबसाइट पे जाएंगे तो एक पे you will find a large amount of material on all sciences, large amount of material. Biographies, if you thought there were only 10 or 12 Indian mathematicians, it lists about 100. Their biographies talks about various results, it talks about, yes, because a lot of material on Indian mathematics and all of it well researched, and there are generally no mistakes in it. Okay, so it's a very good site for you to visit and ask your students to visit. It talks about why was Florence Nightingale actually a mathematician. You know that her basic degree was in maths, and she has a result named after her. Even Napoleon has a result named after her. In fact, he has a triangle named after her. Napoleon's triangle. Yeah, you'll find it.
Sir, sorry, it's being deviated. So you said that argus is a deduction from like these three, like any one of the highest. You said argus can be,
Because right angle is given.
yes. But how come SAS? Argus, like if I have a right angle triangle, first is right angle, another is hypotenuse, and another can be any of the sides.
No, but because of the right angle triangle, you have a Pythagoras theorem. Once you know two of the sides, you know the third side immediately. It doesn't happen in any other way. Unless you know the sign of the theta or the. So basically, knowing two sides of a right angle triangle is basically SSS. It is SSS. Okay. Or if you are even know the second angle and a line, either hypotenuse or the second angle. Because you know two angles, you know the third angle, then it becomes ASC. Okay, or if you know the side between one side, base, and the angle at here, then it becomes ASC. So it is one of the, basically it's one of them. So it doesn't matter. By the way, why is congruence very important? I think the one simple example was very nice. Students see tripods. Why do you see tripods and not quadpods? Why don't you would think that the more the number of legs, the steadier the thing would be? Because triangles, if you fix the level of the points at which their things are there, you have SSS congruence. Tripod cannot shift with the three sides. Once the lengths between the bottoms have been fixed, it cannot shift. But squares, no. So that is why a tripod is always going to be steadier than a quad. A very simple application of something that you are doing in geometry at real life. So you will find that whenever you want to have four things, and you really want to make them steady, you will generally put either a diagonal like this, then you are basically using a thread. That is why kursis which have a diagonal thing are much more steadier. This kursi is never going to be. This stool, if you sit and you can sort of really do a nice boogie dance on it. You can shift. But try it on a tripod, you can't. You just end up sort of roughing up your back of your trousers or whatever you wear. That will just go off. Okay, thank you. So I would have liked to talk about a lot more here, but we're done. Okay? Thank you. Yeah, I'll just take that. I'll just keep this. Yeah, best. Thank you. This is how you.
Excellent.